I'd like to spend just a little bit of time focusing in on this thing called salinity. And to begin with, let's make sure we understand how it is defined. And so salinity really is just a measure of how much salt is in a given amount of water. And we use mass, and we've talked about that before. The mass of dissolved salt in a given mass of water. So with that as a definition, any idea what the average salinity of the ocean is? Well, it's about 35 grams of salt for every 1,000 grams of water, or 35 grams per kilogram. All right, so 35 grams of salt for every 1 kilogram of water. And as we saw when we talked about water as a solvent, we saw how the bipolar nature of water acts as a solvent and breaks up the NaCl ions into their separate parts. It also does the same thing with the MgSO4 that we talked about. And so that's how we get salty water. But where did the oceans get that salt from originally? Well, if you think back to the hydrologic cycle, right? We have that surface runoff, river flow, groundwater flow, and as that water travels through those things, it tends to dissolve salts and minerals, right? That's contained in the rocks that it's passing over and through. And so what that means is as the hydrologic cycle keeps going, more and more of these salts are carried into the ocean with each pass through the hydrologic cycle. So back to my oversimplified or my super simplified picture of the hydrologic cycle. We get evaporation, which, as I explained with distillation and the like, we get just plain old water, no salts involved. So just plain old H2O goes up into the sky, right? Condenses, forms clouds, snows, rains, sleets, hails, whatever, comes back down, travels through the runoff, picks up some additional salts and dumps it back into the ocean and starts over. So hopefully you can see from this picture how we would get this continual adding of salt to the ocean. At this point you may be thinking, okay, that's nice, so what? Well, here's the so what. That process can actually be used to estimate the age of the Earth. And I've got a link here to an article if you want to go dig deeper into this. But here's what the conclusion, the amazing thing is, that if you used secular evolutionary models, right, that don't account for God or anything, they come up with a 40 to 60 million years as the age of the Earth using the salinity model. That is way short of the standard published 4.6 billion years for the age of the Earth that so many textbooks and that publish. So even an evolutionist model supports a young Earth, not billions of years, but millions of years. And as we go through this course, you're going to see that there's more evidence that says it's even younger than that.